Okay, so the next speaker is Zirui Zhang from the University of Glasgow. The title of his talk is Time-Dependent Contextual Feedback Signals Increase V1 Responses to Unpredictable Scene Information. Thank you.
So hi, I'm Zirui Zhang from University of Glasgow. Today I would like to talk about my 3T FRM study. Time-dependent contextual feedback signals increase V1 responses to unpredictable sensory input. So our visual predictions generate from the previous experience and the contextual help us to understand the world based on the limited information. So for example, if we have a look at this symbol, from my personal experience, I would say this is the English letter B or number 13. So what if we add some surrounding information? It becomes the English letter B. And what if we change another scenario? It becomes the 13. So under the predictive coding account, the compatible feedforward and feedback signals are explained the way when possible. So only the information need established further consideration will reach the next stage. And our brain also works like that. So here's a study of the apparent motion. So in this study, they have up and down two white boxes and flashed alternatively. It would generate a motion illusion. And in this study, they also added a white box in the trajectory of this illusory motion. And when this visual stimuli, their onset and motion direction can be predicted by the surrounding illusory motion, it invoked smaller signal changes in the primary visual cortex. And so to test the feedback and feedforward signals separately, in 2010, Smith and Muckli developed an occlusion paradigm which can use the white box to occlude the lower right part of the image to isolate the feedback signal. And in this study, they found the occluded area also shows the similar patterns from their visual surrounding information. So based on that, our research aimed to test whether the target feedforward input of the natural scene information could be also influenced by the prediction generated from the surrounding information, and whether the inconsistent surrounding information and the target could generate significantly higher response than the consistent condition. And what if we add the surrounding information before or after the target? Would that cause any differences? So to test our hypothesis and the research question, we used the 3D MRI to design a dynamic paradigm. So we first selected 10 grayscale images from 5 natural scene categories. And here's an example of our mean trails. So we can see in the mean trails, the lower right part of the image was always shown in every trail. So for the target only as our baseline, that was a whole trail. So to test the consistency effect, so we also have like 4 conditions. We added consistent or consistent surrounding information around the target. And to make sure the predictions could be generated from the surrounding information before the target showed up, we have 2 before conditions which are adding surrounding information before the target. And for the contrast, we also have conditions that are adding the surrounding information after the target. So the right side is an example of our consistent condition, consistent before condition. So in my study, it's very important to make sure the participant fixes their eyes in the central course. So we have a response task. They need to press the button to respond to random color changes of the central course. So then to define the region of interest, we use the 3 types of mapping trails, which are high flickering checkboard located in 3 different areas corresponding to the lower right target, the target border, and the surround. And then we use the general linear model contrast to map the area of the target. And then we use the retinotopic polar angle to define the boundaries of the primary visual cortex. And then finally, we selected the region of interest related to the target area in the primary visual cortex. So then we use the deconvolution analysis to select the deconvolution point containing the peak of the signals to do the contrast for the response amplitude between conditions within our region of interest. So we first get the target-only baseline, both signal changes as so to compare with the other conditions. And then we put all other conditions together, which are having the surrounding information with the target together to compare with the target-only condition. So we can say if we add surrounding information to the target, it generated significantly higher response than the target only. And we also do the further test to do the comparison of the 4 subconditions with the target only. So here's the before conditions, which means we add the surrounding information before the target. And in this page, we can see only as the inconsistent surrounding information before target generated significantly higher response than the target only. However, if the surrounding information and the target information from the same image, this kind of prediction cannot increase the both signal changes than the target compared with the target only. So however, in the after conditions, whatever we add the consistent or inconsistent surrounding information after the target, both of them invoke significantly higher response than the target only. And so to test, following that, to test the consistency effect in the before and after condition separately, we also, we can find only in the before conditions, we found this such significant consistency effect. So in the inconsistent conditions is higher than the consistent condition. But however, after they are all in the same level, they don't have any significant differences. So in conclusion, we have 3 findings. The first one is top-down surrounding information contributes to the bold signal in response to bottom-up activation in V1. And the top-down contextual feedback signals increase V1 responses, but only to unpredictable bottom-up natural information. And if the surround provides the predictable contextual feedback to V1, the bold signals is reduced relative to all other conditions. So I would like to thank my lab members who contribute to this project, Angus Patton, Lucy Petro, Lars Muckli, and Clement Abdekola, and 2 of our astronaut collaborators, the Bill Phillips from University of Stirling and the Christian from Netherlands Institute for Neuroscience. And thanks for your attention.
Thank you very much for the talk. And we have time for a bit of question sessions. I can see Kalinin, please.
Hi. I have a question for you. In the inconsistent case, you focus on the amplitude differences between the consistent and inconsistent cases, but I noticed that in the inconsistent case, it also seems that the bold response were more elongated over time. So how do you account for this extended temporal response in the inconsistent case?
So can you repeat your question?
It looked like in the last slide that you showed, the last data slide, like maybe one before. Yeah, this one. Mm-hmm. It looks like the inconsistent after is also wider in time. So I was wondering what you think is causing this difference in the elongated temporal response.
So that is a good point. I have never considered about that, but so we just do the statistical analysis is both significant, so probably they are not have so many differences. And if we have a look at this after condition, they are all quite similar, so it's not have so many differences between the conditions. So.
Okay, thank you.
Thank you very much. We have another question here. So just a clarification question. How many participants contributed to this measured data?
So it's 23 subjects report in this report.
Thank you. And another question here. Did you look at the spatial distribution of the consistent, inconsistent responses?
No, we haven't.
Yes, since we are continuing, there's one more question since we have a bit of time. Did you look at for any relation to activation of secondary visual regions?
Not yet, but we want to test our result, how to compare with the previous study. The previous study also focused on the V1, but we still have maybe have some plan to look the V2, V3, and so on.
Thank you very much. We'll conclude the question session and thank the speaker again. Actually, Marta suggests that we wait a bit because the next speaker is not due for another couple of minutes. So we'll just take a little bit of rest.